In the previous video, I have introduced to you the concept of this tutorial of simple AI. Now let's create our new project and implement the changes that we require to run the project as I have in the video. First, let's create a new project, call it whatever name you think is appropriate, and create the project using a 3D template. When it's done creating, let's drag our package that you have downloaded from the GitHub into our project and import all the assets. So you should have every asset imported now in Unity. Let's go to the scene folder and let's click on tutorial simple AI. And we have our scene. So as I said before, we need to introduce some changes so the project runs as I have in my project. So let's go to the, for example, skeleton tags, and it has enemy tag on it. Okay, a male casual has tag player on it, so it should be good because we will be using those tags to verify, especially the player tag, if this our enemy sees our player. Okay, now let's go to asset store. First of all, let's search for a RPG BGM. And there it is, BGM RPG Dungeon. And let's import it or download and import. Okay, this should be one file, RPG Dungeon Wave. Next, let's type 44.1. And we should see the 44.1 general library. Let's click on it, download it, and import into your project. Let's click import all, although we will use only one of those sounds. Okay, so when you are done, you should have those two folders, 44.1 and RPG BGM. Let's go to environment, and here we have our output is background game mixer, and audio clip should be RPG Dungeon, so it should automatically import it. And second one is on the male casual. And in the audio source, we should have footsteps stone single 15. And also on the skeleton, we should see a bone step inside our footsteps audio. Footsteps audio plays when the skeleton makes a step. There is an event in the animation of the skeleton, and male casual also have this footsteps stone single 15 on its footstep audio. Okay, let's press play and check out what we've got right now. We have our player that can move using WASD or arrows, and the skeleton that just stands here and do nothing. So we need to change it. We want the skeleton to behave somehow, to see the player when the player passes him, and also to wander around when he does nothing instead of standing still, and also chase the player when it spots the player. So let's get onto it. Just one more thing, let's take a look at the scripts that we currently have. Let's start with universal movement. So universal movement script just accesses the character controller for the game object, and it requires it, so it creates it if there is no character controller on it. We also want to access animator, and we have speed and rotation time. So we will use animator in the custom script, so subscripts of our universal movement. And in universal movement, we only have a move method that allows us to move our character, and rotation method that allows us to rotate our character. And the interesting hack here is this statement that prevents character from rotating when it walks backwards, because this code from quaternion.slurp doesn't really work well. It creates a shaky effect, so this hack allows me to prevent this for this video. I'm pretty sure we can come up with something better here. So let's move to player movement. Our player movement script uses update to get the input from the player, set the velocity in our animator, and call move. And do mind that move is called in update because we are using character controller. If you would use rigid body, the move command should be called in our fixed update. Next, let's check the skeleton movement. In the skeleton movement, we override our move method to set different values to our animator. Otherwise, we could move this code to the base class, to universal movement. In anyways, we are calling the base move and passing the global direction, and the global direction will be passed from the AI system. So that's why the skeleton has a little bit different script than our player. Let's go back to our project and let's think how a AI system should work. Well, basically there should be a system that accesses the information from the world, so what the enemy sees, and using those information it can decide what should our NPC do in this very moment. So first of all, we need to create some kind of interface to access the information from the world. So we will do that by going to Assets, creating a new folder called AI. Let's open it up, and let's create a new C# script called agent. Let's open the script up. Okay, let's delete this code that we have, and we will only create public game object and target. So basically an agent will have a reference to a target, and we will set this reference through a sense script like a vision or a hearing, and this will set this target value to either be some kind of a game object or null. Our AI system will be able to access this target value, and if this is not null, then it will start performing some action. So let's go to Unity, and now let's drag our agent script onto our skeleton. Okay, so we can minimize the audio source, we can minimize the controller and animator, and we can see that our skeleton has skeleton movement script, a footstep audio, and agent script that has the target field. Last script that we will implement in this video is vision sense. So let's create a new C# script in our AI folder, and let's call it vision. Let's open it up. What we'll want here is to create a public string target tag, and let's preset it to be player. That's why it was important that we have our player tagged, so our casual man casual tagged as a player. Okay, and another thing we need is to have public agent data. So this will be a reference to our agent script. Now we will need to have some kind of a place where our vision will shoot the raycast into our target to see if the enemy sees the target, because obviously we assume that our enemy has some kind of eyes that it can see things through. So we will create a separate game object representing our eyes, so our raycast can be shot from there. So to make it so, we will need to call awake, and to access our agent data we will have to call our agent data. We will have to call the get component in parent, and we will get the agent type. So now we will have the access to our agent. Now there is another reason why we want to place vision on a separate game object. We are going to use colliders to check if the player is in range of vision of our enemy. So we are going to call onTrigger stay. This way we are not going to call this method of raycasting every time, so on every update. Instead we are going to call only when the player enters the vision area of our enemy. So this way we will create a game object called target equals collision, or other in my case, dot game object. Now let's call string dot tag. Now we want to get the tag from this game object, so string tag equals target dot tag. Now if our tag is equal or equals to target tag, and if it is false, we will want to return. We don't want to shoot raycast if our player is not in range of our sight, if we see something else. Next, if it is indeed our player who entered our enemy's sight area, we will call vector3 the agent position equals game object transform dot position. Next, we will want to have the target position, so vector 3 target position equals target game object or transform and position. And next we will want to create vector 3 direction. So we want to know in which direction should our enemy look at and chase, basically. So target position minus agent position. Okay. Now we will want to shoot a raycast to see if we can actually see the player, if he isn't behind some kind of obstacle. So ray equals new ray, and we will call our agent position and direction dot normalized. Next we need to create a raycast hit, call it hit, and to visualize the raycast we can call debug dot draw ray, and we can call agent position and direction. So it should shoot a ray in our direction of our player, and it should be visible in the editor. Next we will call the physics dot raycast to actually shoot the ray and check if our ray collides with the player collider. So ray, and we want out hit and direction dot magnitude. And in this case, if this returns true, this means we have hit something. So if our hit dot collider dot game object dot tag is equals to target tag, if this is so, we will call agent data dot agent target equals target. So basically we set the target to be target in our agent script, and our AI can access this agent data.target and say, okay, if it is not null, we are going to proceed to chase this target, and if it is null, we are going to stand still or wander around the area, and we will call return. Well, if it is false, so if our hit.collider.gameObject.tag doesn't equal our target tag, so the player, we are going to set our agent data.target to be null. And if our target is null, then the agent will either wander around or be idle. And last thing we need is to account for what happens if our player walks away from the zone that our enemy can see. So let's call on trigger exit, and if our agent data.target is different than null, and if our other game object is equals to agent.target, so if our player has walked away from the zone that our enemy can see, we can set agent data.target equals null. Okay, so that's it for our vision script. Let's go back to Unity. So now what we need to do is to give our skeleton eyes. So let's click on our skeleton and 3D object and give it a cube. Well, it isn't exactly an eye, but it's better than nothing. So let's bring it up a bit, and we can disable the mesh here. Okay, and this will be the field of view of our skeleton. So let's go to edit collider and edit it a bit. You can use Ctrl to move a one Unity unit, and we can modify this to be a little bigger, so our skeleton has some area of vision. Okay, I think this is pretty good, and as I said before, those will be his eyes. Well, we can get it a little higher and again edit our collider to be a little lower. Okay, so basically this is the area of vision of our skeleton. And now what we need to do here is rename it to eyes and drag a vision script onto it. Now, of course, you could use some kind of mesh collider to make it a little bit like a cone, but for our purposes, this is enough. Let's make sure that eyes, the box collider, is set as trigger, and we can choose the skeleton to see the agent, and we can now play. And when we walk towards the skeleton into his area of view, we can see that agent script now has target male casual, and the skeleton is shooting its ray towards our player. Let's walk away, and we can see that target is now none, so we have walked away from our skeleton. In this video, this is all. In the next one, we will start creating behaviors for our skeleton to look and walk towards our player.